Hello everyone, so this is going to be a solution for practice problem 10.7 from the Fundamentals of Electric Circuits by Alexander and Sadiku. So this question was a request that I got to solve the solution for. So this question, let's take a look. It says find I naught in the circuit in this figure using the concept of source transformation. So before we get into this solution, I think it'd be good to review source transformation. Basically, source transformation, what it is you can take a voltage source in series with a resistor or impedance, and you can convert it into a current source in parallel with the same resistor or the impedance. And you can go back and forth. So you can go from this to this, or you can go from this to this. Hence, I put the directional hands in both directions. So how exactly do we do that? So I have it written down here. I'll erase it and write it again just so that it's very clear. So when I say going from left to right, what I mean by that is if you're going from a voltage source in series with a resistor or impedance to a current source in parallel with said resistor or impedance, if you want to find what is this current value, right? Basically, the current value will be your voltage source divided by whatever that resistor or impedance is. Okay, so basically we're going to calculate current source in other words I by doing the voltage source divided by this impedance. In this case I'm using impedances just because the problem is an AC problem and we're using impedances, but this is the same theorem in DC as well. So if you have a resistor, it's the same thing. All right. The impedance in your new source transformation, this is going to be exactly the same as this. So you don't have to do any conversion for your impedance or resistor. Likewise, you can go backwards from the current source version into this guy. Okay. Basically, we calculate now the voltage source by doing your current source I times the impedance or the resistor. Okay, it's relatively, the actual transformation is simple. Now, applying it to a problem, it can be a bit challenging. Okay, so let's take a look at this problem. So the problem is given here, okay, and they drew it here with the resistors and inductors and capacitors and of course the reactances and all that stuff. I find these types of problems to be easier if you replace the resistors, capacitors, inductors, right? If you replace them with like a block. Okay, so for example, what I did, this resistor and this capacitance, right? The overall impedance of the resistance and in this case the reactance, right? Because they're in series, you would just combine them together. So you would just get 4 minus J3. And I just make it one big block like this. I do the same thing for this resistor and this impedance and this reactance. And I do the same thing for this and for this. So basically this is going to become 2 plus J1 or just 2 plus J. This one will be J5 and this one will be 1 minus 2J. Okay, following the same procedure. And I just convert them into blocks. It's just much easier to visualize. I think a lot of this problem is just visualization. I also drew some nodes here for further visualization. So what I did was I noticed immediately, okay, I have a current source here in parallel with an impedance. Okay, so that's basically the exact shape that we have over here, right? And what we're going to do now is take this and convert it into this. So in order to do that, we follow the procedure that we outlined on the previous page. So what I'm going to do is, maybe I can use a different color here. I'm going to take this guy and I'm gonna convert it into this. Okay, maybe I'll just make this arrow a little bigger. Okay, so let's start with the easy part first, which is basically the impedance is going to stay the same. Okay, let me just move this because it's kind of in the way. Okay, whatever, like this is fine. This impedance 4 minus J3, it's going to be the same in your equivalent, in your source transformations. That part's easy. Okay, the other part, which is basically finding the voltage source, right? It's not difficult, but you have to do a calculation. It's basically going to be the current times this impedance. Okay, so it's essentially going to be, let's see where I can fit it. It's going to be 12 angle 90 times 4 minus J3, like this. That's going to be the value of that voltage source. Okay. If you have a TI-89, it's very easy to calculate this. Okay. You can just put them both. It doesn't matter what form, polar or rectangular, and the TI-89 accepts it, and you'll have no problem with that. If you don't, you'll have to convert one of these to polar, one of these to rectangular, and then work it out that way. So that's this step. So once you have this circuit, right, immediately you see, hey, look, I have this impedance in series. So I can combine these two in series, right, and make just a bigger block over here. So that's what I have on the next page. I actually calculated the, I did this calculation for you. So it's right over here. Okay. There is, by the way, a TI-89 simulator. So if we go here to Safari, and you go and you search TI-89 simulator, it should be working. You just click on the first link, and hopefully it'll work. Sometimes it doesn't work. You have to be careful. Okay, we're lucky today. It looks like it's working. And basically you have a TI-89 on your device. You have to make a couple adjustments because it sort of resets everything. So you got to go to mode, and you got to change, in this case for electrical engineering, you should change it to degree, the angle. And a complex format, let's change it to polar for this particular calculation. Let's see what else I want to do. Yeah, for the exact approximate setting, set it to approximate. Otherwise, it's going to give you many, many decimals, it's kind of too much. Okay, so I think that's it. You can hit enter to save, and now you can just start plugging numbers in. So let's do the calculation that we were doing for the voltage source, right? It's 12. When you put things in polar form, by the way, you have to put them in parentheses. Otherwise the TI-89 won't recognize it. So 12 at an angle 9. Whoops. And this is another problem with the simulator. Sometimes it gets a little glitchy like this, but you can adjust it and get away with it. Okay, so here's 12 at an angle of 90, and we're going to multiply by 4 minus J3. Now this obviously doesn't have J, it has I. You hit second and catalog, you get the I, and then you just put 3. You don't have to put I times 3, it recognizes it. So you go like this, and you hit enter, and you get the answer in polar form. Okay, I set it so that you can get it in polar form, but you could always change that mode to rectangular, and it'll give it to you in rectangular form. So that's what it is, 60 at an angle 53.13. So if you go back here to my solution, you'll see that's exactly what I have here. Okay, I also combined this and this together to make one big impedance, and I moved the nodes to a more convenient location. What I can do, let me remove these nodes for now, and then I'll show you what I did. Right, so basically this is a combination of this plus this. So we have here, let's do it. So if you want to now do things in rectangular, you hit mode, scroll down to complex format, and change it to rectangular, hit enter. And now you can put stuff in rectangular. So 4 minus J3 plus, because they're in series, 2 plus J, that's it, 2 plus J. And you get your answer in rectangular form, 6 minus 2j, which is exactly what I have. So now looking at this, I see immediately a voltage source in series with an impedance. So that's exactly the shape I have for the voltage source, right? And I can convert that into a current source in parallel with the same impedance. So that's why I have the nodes here. All right, let me just move this J5 over so I can do the next transformation. So I'll use a different color here. I'm going to now take this. Let me make it like this maybe so I can get the... Okay. I'm going to take that and I'm going to convert it into this. Notice I kept the same nodes as I have over here. All right, so now I convert it in, and let me move the J5 as I did like this so that I have room. And there we go, right? I'm going to take this and convert it into a current source in parallel with an impedance. This impedance is 6 minus 2j. It's the same impedance, but we have to calculate the value of the current source. So the way we do that, here's your current, right? It's going to be the voltage source that we had, 60 at an angle of 53.13 degrees. And we divide by the impedance. And again, we can use the TI-89 simulator. So we had, let's change the mode, by the way, to polar. So we're going to take 60 at an angle 53. In fact, you can even just grab this guy. You see, you can grab the old one. Okay. You take that and you divide by this impedance. Okay, and we get here the value of the current. So it's 9.48. Let's write it down. 9.487. Okay, I added an extra decimal. I like to round at the end. So just to avoid rounding error, I take an extra decimal. Okay, and then we put the angle, which is 71.56. All right, so that's going to be this. It's going to be this value over here, this current source value. Alrighty. The next step now will be to combine these two. Now, it might be tempting to sort of combine all these three, but the problem is if you combine these three in parallel, you sort of ruin the current here because it's not going to be the same circuit. Basically, if you combine all these three into one big block, you're going to be calculating the overall current, which is just this value. It's not what they want. And the problem, they want just the current through this impedance. So the idea is you want to sort of leave this impedance untouched so that you can just get the current through it. All right, so it's better to just do these two impedances in parallel. And then let's see what happens, right? So if I combine those two impedances in parallel, I did the calculation for you, all right? But I'll show you how I did it. Okay, let's erase it for now. And you'll see exactly how I did it. The parallel combination, right? I mean, this is just straight, it's like the same thing as you would do for parallel resistors, right? So let's call it, just for the sake of calling it something, let's call it Z parallel. So it's going to be 1 over, and then you do, 1 over 6 minus 2j plus 1 over j5, like so. Okay. And we can do that in the TI-89 simulator. I'm going to switch it to rectangular. Usually for impedances, I like to keep them in rectangular form, and for the sources, voltage source, current source, I like to put that in polar. So I like to do the individual, like 1 over, for example, 1 over this thing. I do that first, plus, and then I'm going to do 1 over, and we had J5. Like so. And you hit that. So notice the TI-89 simulator also gives you sort of like, It shows you visually what it looks like, just to make sure that you didn't make any mistakes. And then what you got to do, we got to do 1 over that. So I do 1 over, and I grab this guy here, and we get our combined parallel impedance. So it's going to be 3.33 plus J 3.33. So let's write that down. So it looks something like this, right? So this was your current source, and this is the combined impedance. So now, the final step, I'm going to put my nodes over here because I see that I have here a current source in parallel with a resistor, impedance. So I can convert this using source transformation into a voltage source in series with an impedance. And then I get this super simple series circuit. And notice that even when I do that, this impedance has remained untouched, which is very important. You don't want to modify this impedance because you want to calculate the true current through it. So let's do that. Okay, so let's, I don't know, we can use a different color here, maybe blue. All right. Let me just sort of, I'll do what I did on the previous page, like this, like this. So we can grab, take this guy, all right, and we're going to convert it into this. Okay. So the impedance value itself is going to stay the same. And the voltage source, we have to calculate it, right? That voltage source is going to be the current source that we had previously times the impedance. So it's going to be 9.487 at an angle of 71.56 degrees times this impedance as like so. Okay, so we'll go back to the TI-89 simulator to find that value. Okay, so we're going to have, I have the impedance already there, so I can copy that. That value, but let's change first the mode to polar. It's just going to be easier to work with, as I said. So let's find the current. The current was that 9.48. Let's scroll up. There it is. So we can use this current. And then we're going to multiply by the this impedance over here. And we get our value. I apologize for this glitchiness for the TI-89 simulator. That's just the way it is. So our voltage source becomes 44.72 angle 116.57. So we're going to have here, let's write it, 44.72 at an angle 116.57 degrees. So that's going to be your voltage source. I'll try to fit it like this. Okay. Now, basically the current that we're looking for, it's a series circuit, right? So this is in series with this. So in a series circuit, all the elements share the same current. So basically what we're finding is the overall current in this circuit, and that's basically it. So the way you do that is essentially, it's a simple analysis. I'm going to need another page for this, so let me grab this circuit for the next page. And let me actually take this guy so that we can see a little better. All right, basically this current is going to be this voltage source divided by the total impedance. The total impedance, this and this are in series, so you would just add them together. So your final current that you're looking for, I naught, is going to be this voltage divided by the sum of those two resistors. So we're going to have here 3.33 plus J 3.33 plus this impedance over here. So we have the total impedance. Okay. So now the work is just to plug it into the TI-89 simulator. So, okay. This part is easy. That's the voltage source. Now we're going to have to plug in here the impedances. So I like to, as if you probably didn't notice already, I like to put the, I like to make the parentheses already there, so it's just easier for me to plug in. Okay. If you're wondering why I'm doing it so fast, it's just from years of experience. I find you have to be very careful with your parentheses to make sure that your calculator doesn't make any mistakes. So just be very careful with your parentheses. I like to err on the side of having more parentheses than necessary. That's just my style, okay? Anyway, so let's go up, and I like the TI-89 because, as I said, you can see visually what's going on, right? So you see the numerator is the correct voltage, and the denominator is the sum of those two impedances. So you can double check to make sure that you did the right math. Okay, and here is your final answer, okay, for that current. So let's write it down. So it's 9.864 at an angle of 99.46 degrees. Okay, and if you look in the textbook gives you the answer, but it doesn't give you how to get to it, right? So it's exactly the same answer. They have 9.863, right? We have 9.864, right? It's just a rounding thing. It's not a big deal. It's the same answer. So that's how you would solve that problem. Thank you.